Okay, so basically, since I don't have anything rendering this interesting, I'm gonna just do this like little like show off the thing, the math, because yeah, and I'm just kind of reviewing it again because I also tried to like debug this in one of my other like random source project thingies I was doing. So I did it on Windows like ran duplicates of the issue, but I couldn't like figure out the answer. So I'm gonna just go over my planes one more time, or the way I'm checking to determine like what verts to like clamp to like say like here, right? Like the X out and like Y top out, like clip into the cube. Because if you're not really familiar with like clipping, as I'm totally not sure, I'm just kind of figuring it out. Um, you basically want to make sure that like the three verts, like if this triangle is able to be like somehow contained within this cube. So like this cube representing the clip planes, so you have near on Z, far out there. Left would be the left clip plane, right clip plane, bottom and top clip plane. Um, this is like the image of like what I'm trying to clip into, right? So like this triangle clearly, right, there's like pieces. Oh no, I clicked on rendered. There's nothing render. But this triangle clearly could be drawn. It's like it's contained within, like the cube, like the triangle intersects the cube, right? So it's just a matter of trying to figure out like how to get these here, which is like what I've been stuck on, right? Um, so this whole routine here is like what's supposed to do that. And prior to this routine, I get this like region. It's just it's a 32-bit integer, but it just stores like bits of to describe like what regions you were out of when it did the plane tests. Like if you were less than greater than a plane by value. So like this vertex here would be less than the x uh, near plane, or sorry, left plane. Um, Whereas this x here would be greater than the far clip plane, so it's considered out on x, right? And that region would effectively, for this guy, set a bit here, which just means I'm out on the right clip plane, right? But if your bit was set here on the I think that's just the least significant bit, right? You'd be out this way, right? So yeah, and then you could be out bottom side, which is what this vert would be for y, and then these two bits contain y. So like this is bottom clip out, this is top clip out, and then so like these two would have this, or so like this vertex in particular would have this bit combination, right? Whereas this one would have this bit combination, and then this bottom dude would have that bit combination. To describe where they're out. Because currently they're not out of Z um, in this like test. So the Z bits are up here. This right here would be near out, and this would be far out. So that's all this region describes. So like looking at it, right, here I check for if you and the region by 3, if like any bits survived. So if you had like this like current out set, and you and by 3, right, 0x3, you have a bit retained. Whereas if you weren't out of that plane and you're just out of the y plane and you ended by 3, you get 0 back. So you check for any x and any y, because C hexadecimal has the y out, right? And then you just check if you were x1, which is the x out, right? Left, or and if this was not true, it would just be right clip. So if this was true, you were x, so left clip, sorry, and then you'd be right if this failed. And then if this is true, 0x4, so the bottom clip, you'd be bottom clip, else top clip, so that's result y. And then actually I didn't realize until recently that you could actually be all out, like out of every plane. Like you'd be this way, and below. So like you could be down out here basically. So you should clamp into the cube here. Um, So that's why I check right here 0x30, and 0x30 is just these 2 bits on. And then if 10, right, you'll be near clip because that's where near clip was set, and then far clip was this bit on. Because if you and by 10 and you were this right here, it would be 0, right? So you'd fail and be far clip. Or any other combo bits. You just have to have that bit set, and it's just checking that one there. So, and then, you know, if you fail the initial test, then you check YZ double out, so C and 30, and then you just do the same thing here, and then it's 30 and X, so ZX or XZ, I don't know what's the most mathematically correct, but you just set those again, right? But there's actually a whole different issue where if you weren't double out, right, you were at least out of one because region up at the top said true, so any of the bits were set. If none of them were set, you were just valid, right? And that's how I got like the actual like basic triangles drawing, was just hitting this branch. Very like all the time prior to it hitting like the screen, like coming right into contact with the screen. So in most cases, actually, right now, you're probably hitting this else branch because I don't actually have many or any double outs. So most of this code doesn't actually get ran, to my knowledge. I just want to like double check and it's like, oh, maybe it is or not, and you know. So in the case that you're else, right? So you're just not double out, or I guess triple out in this case. And maybe I'm missing like something about. Well, see, that's the thing though. If you're triple out, you'll at least have hit these two for sure. So that's why I shouldn't have to check for Z anywhere else, at least to what I understand at the moment. I'm probably missing something, but I don't know on that in particular. But to not detract too much down here, right? I need to figure out like, cause see if you were double out, it's just a clamp to the plane, right? I can just, like, I know you're definitely not, like you're definitely somewhere out here, so like if you were X, or sorry, Y and X out, you would just be right here where this like line is, right? You just clamp to those planes and retain your Z because the Z was in here. So just be X and Y, but retain that Z. Whereas if you're only one out, you actually need to like straight up like figure out where you intersect with the line that's the plane. So like this here, for instance, is well, actually probably better to put it, well, that's in, so it has to be like out a little, like here, I guess, let's say. You're definitely out of X, right? Just X though. And you can see the lines even in like just this modeling software, Blender, that like you intersect, and if I just sort of view it in orthographic, you can see it just intersects where the far like clip plane is. So like you need to figure out where along sort of the line this conceptually made. Now actually if you were to draw this line explicitly, this would be top to bottom, and that's how you draw this line segment, which actually might be my bug now that I think about it, but I mean I should look at that in a second, but it just keep the concept simple, like you know, you need to figure out where you intersect with this plane, right? Or like where the line would lie if you were to like subdivide a triangle, which is what I'm trying to do to like get an okay image. So that's why here I'm checking for you know, X, X, and then Y, Y. Like so basically you just check the region and you set the bottom and top planes. So line point A and line point B, these are just saying the component to what plane was out, because at least you were out of one of them. And again, now that I think about it, like the type of line that this is making right now is sort of this line segment here, like a line segment that's going left to right, and not really this line explicitly. But I did do a test in my like one of my other projects, and like ran it on Windows so I could have a debugger. And like I tested a test line that was just a similar case to this, where it was only out of one of these planes. Um, and I remember it did get the right result for like one vert, but the other vert kind of looked right. Um, so I just sort of assumed that that worked, but maybe I do actually need to make the bottom to top as a line segment I actually test across, like against, to like figure out where exactly these line up. Um, so it's either one of the two. So either I'm right in my current assumptions where I just set, so like if you were out of one of the x planes, so in this case you are, you'd hit this branch, right? And then you'd set the sort of left bottom, like the left point to the left clip plane's value. So this value over here. So like I think right now it's negative 100. And then 100 over here for the right clip plane would be on B. So it's A to B like this. But that again would make this line. So that's why I'm still kind of like, I'm not sure if that's right. But you get like one line, and then the other components are just set to 0, so that's why it would just be that in this case. And then you would straight up come down here. Well, you need to figure out where the other two verts are, because this routine operates only on one vertex at a time. So you need to figure out where the other two vertexes are, pretty much. So like where B and C are. And the way I do that is just this check, right? Because if your vertex right now is 2, then you're like conceptually C in the counterclockwise round triangle. So you should be 0 for B, looking from C's perspective. If this was not 2, then you were like 1 or 0, so you can add 1 to get 2 or 1, depending on which one you were. And then it's just the same thing here, except you're testing like the value of this, like where B was. Because if you're like tests, like if this vertex here was 1, so it was like 0, 1, 2, and that's counterclock, right? So 0, 1, 2. And this guy here was 1, like by base. So like BIND became 2, right? Because 1 does not equal 2, so you just do 1 plus that equals 2. You need to go from this. So this would be 2 equals 2, because you're now C, right? And then the actual, like from B's perspective or 1's perspective, you're trying to like test against this vert. So you'd just be 0 in this case if you were like looking from him. But if you're looking from him, you'd fail both these and you just get, or sorry, wait. No, sorry, you get 0 here, because that would fail, because your next is 1. So you get 0 plus 1 equals 1. 1 fails. Oh, I think I found my bug. Unless I'm wrong about that. Well, this is just checking too, but if you fail, you don't want to be 1 explicitly. Because you could have been, or sorry, if you fail this, you don't want to be 0. Oh, I'm dumb. I'm not thinking right. This would just do 1 plus 1, because this isn't 2. And then you get 2 here. So like looking from him, right, 0, like the actual, like you're just starting here, you get 0 does not equal 2. So this does not be, like you're not setting 0. So you just fail this, jump over here, and that equals 1. And then here it's 1 does not equal 2, or 1 equals 2, which is false, right? So this is not set, and then you just set this. So you get 2, which completes the triangle. And then they just pull the vertex out of the current triangle that they are set to, or like the ones that you're looking to try to compare to, or make lines, because you have to like still make line segments. So like, I guess geometrically you're sort of comparing against this like near to far, and then like from this dude here, you're going like this, and then you're actually like checking those lines. because those lines aren't really, they're not explicit. You have to like make them. So this routine here will run, and it will check for the like closest point, right? Trying to find these 2 points, and then you get them, hopefully. I did have this whole like failure check thing earlier, and I did test and I got super wrong results from not like getting the right, or like if I have the failure check in there, I get kind of okay looking results. But like in the current cases, or like my current case of drawing, everything should always like I should always get non-degenerate like intersections against the line. Um, so I think my routine's wrong. So there's like 2 parts that could be wrong: is the line routine or uh, the like I need to actually do for like if you were X, set bottom and top here instead of left and right. Um, kind of a thing. There's probably some like math reason why you do that that I don't know, but hey, I'll have to like look at that more. Um, and then yeah, so you basically just get your result, and then you write into this vertex array first, and just like the first position, you're also just setting a color for this, um, and then you just add. So you have one new vertex in the array, and this conceptually is, it's like if I were here, the line or the point here, the new vertex here would be first, and result would be this dude. Because if you're looking from this vertex's perspective, and you want to follow counterclockwise winding, it would go, you know, like this. So like this is the current one, over and out, counterclock. Because this is clockwise, this counter. And that's why I do it that way. And because this is important because all the winding out here, like it relies entirely on the fact that first is put in first, and then result is set to this final check vertex thing that's then written to the array, and then you add the count. Because all cases will generate one, right? Because you were like totally in, or you were double out, or you did 2 like line intersections and generated 2 more vertexes. So yeah, so I'm gonna have to check these 2 out, or really it's just one routine. I have to go check, and then I need to look into like the math of this. So yeah, I'm gonna end this now.